This epidemiology lesson is about the basics of the death rates that we frequently calculate. It seems odd that we would calculate dead a number of different ways, but each of the calculations that we complete based on death tell us something different. A couple of things to keep in mind. The death information that we get in the health world comes usually from death certificates or medical records. On those cases, or in that case, the information that we have usually only identifies one particular cause of death, while in fact there may be multiple causes of death. For instance, someone may die of an infectious disease, a sepsis is what it's called, because of a necrotic toe from being a diabetic. Well, in that case, there's three different things there that could be recorded on the death certificate. The real cause of death is probably diabetes, but in most cases, that death certificate will say something like sepsis. So it's important to keep in mind that the death information is only as good as the way we collect it. But with all of that aside, we can calculate death rates a number of ways. And the four ways that we're going to discuss now are the base root of those calculations. There's other calculations that you can continue on, like age-specific death rate, neonatal death rate, perinatal death rate, that are just similarities to the ones we'll calculate here, or derivatives of these. So with that said, we'll just calculate case fatality rate, cause-specific fatality rate, proportionate mortality rate or proportional mortality rate, and crude death rate. We'll start with crude death rate because it's the most basic. Crude death rate is the number of people in the population who died as a simple proportion. So if we take the little bit of wedge here, this number of people who died out of the total population. And in this case, with our calculation, we have the number of people who died, 800. 800 divided by 2 million. So 800 divided by 2 million will give us 4 per 10,000. By taking 800 divided by 2 million. Now those 800 people, they account for all of the deaths that occurred. If we moved that up and we took a little line on all of these dead people became the new population here. So the new population was dead, or death, here. Then we could easily calculate what we call the proportionate mortality. Now this little graph, this pie, of all the death, will be split into many different wedges. Right? Lots of different sizes. Some are going to have a lot of death. Some are only going to be a little bit. So on and so forth. So this particular disease, there's 5,000 people in 2 million that had it, but only 80 died. So we're going to consider just this little wedge right here. Those people died from this particular disease. So out of the 800 total deaths, 80 were from this disease out of the 800 total deaths, and that equals 10%. So that's proportionate mortality. Proportionate mortality is usually the calculation we use that tells us the top causes of death. So it ranks all of the deaths from the most to the least and gives it a percentage of the whole. And that's proportionate mortality rate. The number of people who died from the disease divided by the total deaths. That doesn't give us the whole picture. It tells us how frequently people die from a particular disease, but it doesn't, or out of the, let me back up, excuse me. It tells us the amount of dead people in the community that died from that particular disease, sometimes what we call the burden of disease. But it doesn't tell us how many people are affected by that disease. Prevalence tells us that, but we can combine the idea of prevalence with these death rates to get what we call a case fatality rate. So case fatality rate takes the people with the disease, so we're going to say with the disease, if I can get my screenwriter to work. And there's going to be some amount of people with that disease that die. Right? If that circle represents everybody who has the disease, these 5,000 people, some of them are going to die. In this case, 80. So 80 out of 5,000, if we calculate 80 divided by 5,000, this tells us how deadly the particular disease is. In this case, 1.6% of all the people who get this disease will end up dead. This is frequently called the deadliness calculation. It tells us how deadly a particular disease is. Something like Ebola has a very high case fatality rate in the 90% rate. The common cold, on the other hand, has nearly a 0% case fatality rate because hardly anyone dies from the common cold compared to those who are infected. Now, if you look just at proportionate mortality or just at case fatality, sometimes you don't see the whole impact on the community. You see the characteristics of the particular disease, how deadly it is, or how, as a proportion of all deaths, how often it is killing people. But it doesn't tell you that the impact of the disease on the community as a whole. That calculation is cause-specific mortality. So in this case, we calculate the burden of disease on the whole population. So in this case, our circle is population. And if you look at the total population, it's only going to be this little wedge here from the crude death rate. So it's only going to be just a little bit of the total population that is really has any effect by this disease. We calculate that by taking 80, dividing it by 2 million, and that's going to give us 4 per 100,000. So very few people are affected in the population by this or die from it. And that's how we calculate the various death rates. Now, again, you can take these basic calculations and embellish them with other characteristics. Things like age-specific case fatality rate. So in that case, you'd take a portion of this little piece of the pie, and that would be your calculation for age-specific case fatality rate, and so on and so forth. I hope this has been helpful in helping you understand death rates.